So in this lesson, we're going to simplify algebraic expressions using the distributive property. And in a previous lesson, we did talk about using the distributive property to remove parentheses. In this case, though, what's going to happen usually is that when you remove the parentheses using the distributive property, you can still be able to combine like terms. All right, so let's kind of review the distributive property first from a previous lesson. So for example, let's the directions say simplify. And so let's look at this example, number 1. All right, suppose we had 3 times 2x minus 1. So 3 times 2x minus 1. And so remember in a previous lesson, to remove the parentheses, remember this says 3 times, so I'm going to multiply every term in here by 3. So you're going to say 3 times 2x is 6x, and then 3 times a negative 1 is a negative 3. And again, those are not like terms, so this is your answer. You're done. All right, number 2, suppose we had negative 5 times 6x minus 2, let's say. So again, you're going to get rid of the parentheses by distributing a negative 5. So every term in here, you're going to multiply by negative 5. And so negative 5 times 6x is a negative 30x. And then negative 5 times a negative 2. Remember, negative times a negative is a positive. So negative 5 times a negative 2 is a positive 10. And again, those are not like terms, so there's your answer. Number 3, suppose we had negative 2 times 2x minus 3y plus 6. And so notice in this case, the parentheses are 3 terms, but you're still, in this case, you're multiplying by negative 2. So you can distribute the negative 2 through all 3 terms. And so negative 2 times 2x is a negative 4x. A negative 2 times a negative 3y. Remember, negative times a negative is a positive. So negative 2 times a negative 3y is a positive 6y. And then negative 2 times a positive 6 is a negative 12. And again, those 3 terms, they're not like terms, so you cannot combine any of them. All right, number 4, suppose we had this. Suppose we had something that looked like this. And so we had, let's say, 2x minus 7y minus 2, let's say. And so notice, if there's no number out in front, remember that's understood to be a negative 1. So that's understood to be a 1 here. So negative 1. So I can write this. It's a good idea to do that when we go over the next few problems, to write this as negative 1 times 2x minus 7y minus 2. And then I could distribute the negative 1 through here. So negative 1 times 2x is a negative 2x. A negative 1 times a negative 7y is a positive 7y. And then a negative 1 times a negative 2 is a positive 2. And again, those aren't like terms, so there's your answer. Okay, let's look at number 5. All right, number 5, suppose we had this. Suppose we had 3 times x minus 4 plus 8. 3 times x minus 4 plus 8. Okay, so here I need to get rid of the parentheses. I'm going to use the distributive property. So I'm going to say 3 times x is 3x. 3 times a negative 4 is a negative 12, but don't forget that plus 8. Now notice that I have 3 terms now, and so I can combine these constants. So this is where you're going to start combining like terms. And so I know that a negative 12 plus 8, if you don't remember how your sign numbers, use your calculator. So negative 12 plus 8 is a negative 4. So the answer becomes 3x minus 4. So there's your answer. Number 6, suppose you had negative 2 times 5y minus 6 minus, let's say, 2y. Let's say we had that. So negative 2 times 5y minus 6 minus 2y. Now notice the only parentheses you see is this. So if you need to kind of cover up this part here, then go ahead and cover it up. So you're distributing a negative 2 through here. So negative 2 times 5y is a negative 10y, and a negative 2 times a negative 6 is a positive 12. But don't forget, you do have this negative 2y as well. So now those are my 3 terms. Now let's think about combining those like terms. These right here are like terms because they both have the variable y, and the y's are being raised to the same exponent. So this coefficient's negative 10, and this coefficient's negative 2. So negative 10 plus a negative 2. And so negative 10 and a negative 2 is a negative 12. So when I combine these two terms, I get a negative 12y. And this is the only constant, so my answer is going to be negative 12y plus 12. And so that's your answer. That's all you do there. Okay, and so let's look at this example. This is going to be number 7. Suppose we have something that looks like this. So let's say it's 2x minus 3y plus 6 plus, let's say, 2. All right, now, oops, right here. So number 7. So that's what we get. Now remember, in a previous example we did, when we did number 4, if you see how this is just a negative out here, remember that's understood to be a negative 1, so we distribute the negative 1. So same idea here. So if you need to rewrite this, and go ahead and rewrite this. So this becomes negative 1 times 2x minus 3y plus 6, and then plus 2. And so if I distribute the negative 1 through here, I get a negative 1 times 2x, a negative 2x, a negative 1 times a negative 3y is a positive 3y, and then a negative 1 times a positive 6 is a negative 6, and then plus 2. And then the only two terms I can combine are these two, because those are your constant. These are not like terms, because this term has the x in it, this does not. So those are not like terms. The constants are the only like terms. So when I combine those two, negative 6 plus 2, I get a negative 4. So the answer becomes negative 2x plus 3y minus 4. And so that's the answer. Now, you see how there are three terms here, and this term has the x, this term has the y. We tend to write it alphabetically. So we put the x first, then we put the term of the y next, and then the constant is last. Okay, so that's number 7. Okay, let's look at number 8. All right, so number 8, suppose we had this. Suppose we had 5k minus, in parentheses, 3k minus 10. Suppose we had that. All right, again, if you have to, you may want to cover up this part here. You see this 5k? And suppose we did cover that up, and then that right here kind of looks like what we did here. See how there's no number there since it would be a negative 1? So you may want to rewrite this as negative 1. So in other words, this becomes 5k minus 1 times 3k minus 10. That's what we get. Now again, still covering up that 5k, see these two terms inside the parentheses are going to be multiplied by negative 1. So you have to kind of cover some stuff up and think about it. And so when I distribute the negative 1, I'm going to get this. Now I'm going to get 5k. A negative 1 times 3k is a negative 3k. A negative 1 times a negative 10 is a positive 10. And so when I combine these two, these are like terms. When I combine 5k and a negative 3k, I get 2k plus 10. And so that's your answer. Number 9, suppose we had this. Suppose we had 3x plus 4 minus, in parentheses, 6x minus 1. All right, so 3x plus 4 minus 6x plus 1. Now notice that these both have parentheses, and the idea when simplifying an expression with parentheses, you want to use a distributive property. And so remember, there's no number there. That's understood to be a 1 right here, and this would be a negative 1. So you may want to rewrite both of these right here. So you may want to say that's going to equal 1 times 3x plus 4 minus 1 times 6x minus 1. So you may want to do that first. And then let's kind of cover this part up right here, this other one. And so notice that this first set of parentheses, I'm multiplying by 1. So you can distribute that 1. Remember, 1 times anything, any set of expression, any terms rather, any numbers, it's that expression or number. So this becomes 3x plus 4 still. Okay? So if you see a parenthesis up here and there's no number there, it's only going to be 1. So you can just remove the parentheses. So that's just 3x plus 4. Now you got to be careful though, you don't do the same thing here, because this is not a positive 1. That's going to be a negative 1. So you have to distribute. You have to actually make sure you distribute. Because it's not 6x minus 1 that you write. It's going to be negative 1 times 6x is a negative 6x, and then a negative 1 times a negative 1 is a positive 1. So that's what you write. And now I have these 4 terms, and so I can combine like terms. So let's do the let's combine the x's first. So these two are alike because they both have the variable x in it and they both raise to the same power. And so I get 3 and a negative 6 is a negative 3 when I combine those coefficients. And so this becomes a negative 3x. Now the constants, a positive 4 and a positive 1, that's easy, that's just 5. So I get negative 3x plus 5. Okay, number 10. All right, number 10, suppose you had this. Suppose you had, let's see, all right, suppose you had 5 times x plus 2 minus, in parentheses, 3x minus 4. Suppose you had that. All right, it's very similar to number 9, except now in this case we have a 5. It's not a 1. So I'm going to distribute the 5. And over here, again, if you cover this part up, this set of parentheses, you're going to distribute the negative 1. So I'm going to go ahead and rewrite this first. So I'm going to go ahead and rewrite this as this, just to remind you. Now you could have skipped this step, and you could have automatically put a 1 right here and distribute. It does not matter. So you're going to distribute a 5 through here, and over here you're going to distribute a negative 1. Okay? And so 5 times x is 5x. Put equal signs here. And then 5 times 2 is a positive 10. Now over here you distribute negative 1. Negative 1 times 3x is a negative 3x, and then negative 1 times a negative 4 is a positive 4. And so now I'm going to combine like terms. I can combine these two because they both contain the variable x, and both x are being raised to the same power. And these right here are your constants. So 5 and a negative 3 is 2, so I get 2x. And then 10 and 4 is 14, so I get 2x plus 14. And so that's number 10. Okay, number 11. Okay, number 11, suppose we had this. All right, 11. Suppose we had, 2 plus 4 times 6x minus 6. So 2 plus 4 times 6x minus 6. So be a little bit careful here. What some students tend to make a mistake is they want to say 2 plus 4 is 6. That's incorrect. This is not 6. So don't say this right here. Don't say this is 6. That's not true. So it's not 6 times 6x minus 6. That's wrong. Because remember, the order of operations, you got to multiply first before you add. So that's a mistake to add first. Remember, the order of operations, you multiply before you add. So what you got to do first is cover this up and distribute the 4. So you can use distributive property first. So everything in here is going to be multiplied by 4. So you multiply first before you add. So this becomes 2 plus 4 times 6x is 24x. And then positive 4 times a negative 6 is a negative 24. And then combine like terms, I can combine the constants. And so I get 24x, put the x first. And then a 2 and a negative 24 is a negative 22. So there's your answer. All right, let's do a few with fractions in it. So suppose we had 1/3 times 7y minus 1 plus 1/6 times 4y plus 7. I suppose we had that. Okay, so in this case, we're going to distribute the 1/3 here. And over here, we're going to distribute the 1/6. Okay, so don't let the fractions throw you off. You do have to, you have the calculator for one thing, but you do have to remember how to deal with fractions from a previous course. So we have 1/3 times 7. So remember, 1/3 times 7, what that means. Okay, so 1/3 times 7. If you need to, rewrite the 7 as 7 over 1. And so you can multiply the numerators first. So 1 times 7 is 7. And then divided by, and then the denominators, 3 times 1 is 3. And then you can reduce if you can. In this case, I cannot reduce, so I get 7/3. So what that means is this, that 1/3 times 7y is just 7/3 y. So that's what that means, 7/3 y. And over here, 1/3 times negative 1, that's not difficult because that's just a negative 1. 1/3 times negative 1 is a negative 1/3. That's all that is. Okay, now let's look at this. So this is 1/6 times 4. 1/6 times 4y. So let's look at this coefficient 4 first. So 1/6 times 4. I can write 4 as 4 over 1. Now you can reduce first in this case, because you see that 6 and the 4, they both are divisible by 2. And so you can reduce. In other words, you can say 2 and the 4 is 2, 2 and the 6 is 3, and then multiply the numerators. 1 times 2 is 2, 3 times 1 is 3, so you get 2/3. Or you could have done this first. You could have multiplied first. 1 times 4 is 4, 6 times 1 is 6, and then reduce that. They're both divisible by 2, so 4 divided by 2 is 2. 6 divided by 2 is 3. So you get the same thing regardless. But the point here is that 1/6 times 4y is a positive 2/3 y. That's what that is. And then over here, then, 1/6 times 7, that's what you get, 1/6 times 7, 7 over 1. I can't reduce anything here, so I'm just going to multiply the numerators. 1 times 7 is 7, 6 times 1 is 6, you get 7/6. So this is 2/3 y plus 7/6. Okay, so that's what I have. So I have these 4 terms. These two are alike. They're both like terms. They both contain the variable y raised to the first power. Now let's look at the coefficients. So remember looking at coefficients. 7/3 plus 2/3. Now that's easy to do because the denominators are the same. So whenever the denominator is the same, I can just add the numerator. So 7 plus 2 is 9, so I get 9/3. So 7/3 plus 2/3 is 9/3. Now be a little bit careful. Don't add their denominators because these are partitions. So you have 7/3, and then over here in terms of thirds, you have 2 of them. So if you have 7 here and 2 here, altogether you have 9/3, which reduced is 3. So don't leave it as 9/3. You got to write it as 3. So 7/3 y plus 2/3 y is 3y. All right, now let's look at this. So negative 1/3 plus 7/6. Those are my constants. So remember, you can combine constants. So first of all, you have access to calculators. So let's see how to do this in a calculator. Now notice that these denominators are the same. Are different. So you can't combine them like we did this. They have to be the same denominator before you can use this idea. So let's look at a calculator first. So you're going to say in your calculator, remember this is the calculator you're supposed to have in class. So you're going to say negative 1/3. If you have a different calculator, make sure you know how to use it. So negative 1 divided by 3 looks like this. So negative 1/3 plus 7 divided by 6, and then press equal. So when I press equal, I get this decimal. I get 0.8333 repeating. But you don't want to leave it as a decimal. You want to rewrite it back as a fraction. So to change this back to a fraction, you see this PRB right here? Right here? So then, you see right above it in blue is that F to D, so that's fraction to decimal, decimal to fraction. So to get to it, you're going to press the second button. All right, so here's what we're going to do. So once you put this in your calculator, then you're going to say second, and then this PRB button. And then notice when you do that, so you get F to D. All right, so press equal, and now what you get is this fraction, 5/6. So negative 1/3 plus 7/6 is 5/6. And so that's what this is. So this becomes 3y plus 5/6. So there's your answer. Again, don't write as a decimal. There are no decimals in here, so you should not have any decimals in here. All right, now let's talk about how to do this without a calculator. Okay, so remember, in order to add fractions with unlike denominators, you're going to have to first of all find the LCD, and once you find the LCD, you have to write equivalent fractions. So those are the two main ideas when adding fractions with unlike denominators. All right. So the smallest number that 3 and 6 go into, that's what I mean by the least common denominator. So the smallest number that 3 and 6 go into is 6. And so my LCD is going to be 6. I'm going to write two fractions with that denominator 6. And so the idea of equivalent fractions come into play here. So the question is, negative 1/3 is equivalent to what fraction with a denominator 6? And so remember what we did was we said, well, to get a 6 here, I got to multiply this by 2. But what I do to the denominator, I have to do to the numerator. So 2 times a negative 1 is a negative 2. So negative 1/3 is equivalent to negative 2/6. So these two fractions are equivalent. Over here, these denominators are the same, so 7/6 is equivalent to itself. So if the denominators are the same, then the numerators have to be the same. And now, since the denominators are the same, I can combine the numerators. So -2 plus 7 is a positive 5. So I get 5/6, and that's what this was. Okay, so if you need to review some how to add fractions without a calculator or subtract fractions without a calculator, you got to make sure you go to Google and you just look for YouTube videos. It's not that difficult. You just got to review it. Okay, so that's number 12. Let's look at 13. So on 13, let's suppose we had 1/7 times 8y plus 3 plus 1/6 times, let's say, 3y minus 1. So let's say we had that. All right, so I'm going to do one more with fractions and see how we do with it. So again, I'm going to distribute the 1/7. Distribute the 1/7. So I get 1/7 times 8y. So remember, this is what we have. I'm going to go right here. So 1/7 times 8 over 1. So that's 8/7. And I can't reduce that. So it becomes 8/7 y plus 1/7 times 3 over 1 is 3/7. I cannot reduce that either. So that's plus 3/7. So that's what I get here. So this right here is this. Distributing the 1/6 here, I get, let me see if I can get some space here. I get 1/6 times 3. Well, that's 3 over 6, which reduced is 1/2. So this becomes plus 1/2 y. And then 1/6 times a -1 is a -1/6. All right. Okay, so let's combine like terms. So I'm going to combine these two terms here. And so I get 8/7 plus 1/2. So 8/7, its coefficient is 8/7, its coefficient is 1/2. So I get 8/7 plus 1/2. Use your calculator. So in a calculator, I get 8 divided by 7, just like this. So 8 divided by 7 plus 1/2, 1 divided by 2 equals, and I get this. So 1.6428 and so on. All right, but again, you don't want to write this as a decimal. In fact, this decimal doesn't terminate. So what you want to do now is you want to convert this back to a fraction. Okay, now watch what happens when I do that. So remember how to do that, though. You press second, and then P or B. This shows up, and then you press equal. Now see how this looks? That looks a little bit different than the other one when we did this one. So this is a mixed number. So this right here is the mixed number 1 and 9/14. 1 and 9/14. And so remember how to change a mixed number back to an improper fraction. So you're going to say 14 times 1 and then plus 9, plus the numerator. So 14 times 1 is 14, and then 14 plus 9 is 23. So you got 23/14. And so this becomes, right here, this becomes 23/14 y. That's what this is. Okay, now let's look at the constants. You have 3/7 and a -1/6. So 3/7 plus a -1/6. Use your calculator, see what we get. So you're going to say 3 divided by 7 plus a -1 divided by 6. All right, so 3 divided by 7 plus a -1 divided by 6. Or you could have just said 3/7 minus 1 over 6. Does not matter. But with whatever you do, you better get this. I get this idea right here. All right, so I got to convert this back to a fraction. So I'm going to say second, P or B. So you get this fraction to decimal, decimal to fraction. Press equal. And you get this fraction, 11/42. So plus 11 over 42. That's your answer. Okay. All right. So let's do these now, and that's just to kind of review this. Let's do these without using a calculator. So just kind of see if you remember how to add, subtract fractions by finding the LCD. So we have 8/7 plus 1/2. So we got to find the LCD. Remember, you have to find the LCD. So you can't just add the numerators and add the denominators, because remember, when adding, subtracting fractions, your partitions have to be the same. So this is sevenths and this is halves. So The partitions are not the same, so you got to get your partition to be the same. And so this is where the least common denominator comes into play. So the smallest number that 7 and 2 go into is 14, because 7 goes into 14 and 2 goes into 14. So I'm gonna write this as in terms of 14 partitions. So I'm gonna write two fractions, just like this, and I'm gonna write equivalent fraction with the word equivalent fractions. And so I'm going to say 7 times 2 is 14, but what I do to the denominator, I got to do to the numerator. So 8 times 2 is 16. So 8 sevenths is the same as 16 14ths. Kind of makes sense because both of these are divisible by 2, and so I get 8 sevenths back. Over here, I'm going to say 2 times 7 is 14, but again, what I do to the denominator, I got to do to the numerator. 1 times 7 is 7. It kind of makes sense that 7 14ths is 1/2. So 8 sevenths is equivalent to 16 14ths, and then 1/2 is equivalent to 7 14ths. Now, since the denominators are the same, since I have the same partition, since those are partitioned the same, I can just add the numerator. So 16 plus 7 is going to give me 23. So I get 23 14ths, which is what this right here was. Okay? All right, same thing with 3 sevenths minus 1/6. 3 sevenths minus 1/6, or 3 sevenths plus a negative 1/6, doesn't matter. You get the same thing. So when you subtract, you do the same thing. The smallest number that 7 and 2 will go into is 42, so your LCD is 42. 42. All right, so you can say 7 times 6 is 42, but what I do to the denominator, I do to the numerator, so 6 times 3 is 18. 6 times 7 is 42, but what I do to the denominator, I do to the numerator, so 1 times 7 is 7. And so then all you're doing now is saying, since the denominators are the same, you're saying 18 minus 7 is 11 over 42. And that's what we got here. See, 11 over 42. Okay, so that was this part here was a quick review of previous course. All right, so that was 13. Let's look at 14. Okay, 14, suppose we had this. Suppose we had 0.5 times m plus 2 minus 0.4. So 0.5 times m plus 2 minus 0.4. So again, we're dealing with decimals here, so just distribute. Now remember, you don't distribute the 0.5 with this, because you're only multiplying 0.5 by what is inside the parentheses. So 0.5 times 1m is just 0.5m, and 0.5 times 2, if you don't know that 0.5 is a half and half of 2 is 1, use your calculator. So you're saying 0.5 times 2 equals, you're saying 0.5 times 2 equals 1. All right, so it'll be plus 1 and then minus 0.4. And now these are your constants, so combine your constants. There are no other term with the variable m. So when I say 1 plus a negative 0.4, so 1 minus 0.4, I get 0.6. And so this becomes 0.5m plus 0.6. So there's your answer. All right, let's look at this one. Suppose we had 6 times 3x minus 6 minus 2 times x plus 1 and then minus 17x. Suppose we have that. Okay, so notice I have two sets of parentheses. So over here, to get rid of this set of parentheses, I'm going to distribute the 6. And over here, to get rid of the set of parentheses, I'm going to distribute the negative 2. And so this doesn't have parentheses in it. All right, so I'm going to say 6 times 3x is 18x. 6 times a negative 6 is a negative 36. Negative 2 times x is a negative 2x. And then negative 2 times 1 is a negative 2. And don't forget minus 17x. Okay? Now combine like terms. Let's combine the x's first. 18x and a negative 2x and a negative 17x. So we're saying 18 plus a negative 2 plus a negative 17. That's what we're saying. So use your calculator if you need to, but 18 and negative 2 is 16, and 16 and negative 17 is a negative 1. So what that means then is that when I combine 18x and a negative 2x and a negative 17x, I just get a negative x. All right, now I want you to remember this. We prefer to write as negative x. So remember when we wrote this negative 1, you can say negative 1x, but remember, negative 1x is the same thing as negative x, and that's what we prefer. This is what we prefer. Mathematically, we prefer that it be written as negative x. So negative x is the way I'm going to write it. Now your constants, a negative 36 and a negative 2 is a negative 38. So the answer is negative x minus 38. So that's 15. Okay, 16, suppose we had this. Suppose we had 1/2 times 12x minus 4 minus, in parentheses, x minus 5. I suppose we had that. So again, there are two sets of parentheses. So here I'm going to distribute the 1/2, and then here I'm going to distribute the negative 1. So I'm going to go ahead and rewrite it like this. All right, so here I'm going to distribute the 1/2, and here I'm going to distribute the negative 1. So make sure you rewrite the negative right here as negative 1. And so the 1/2 times 12, remember that's just 12 over 2, which is 6. So 1/2 times 12x is 6x. All right, minus 1/2 times 4 is 4/2, which reduced as 2. So 1/2 times a negative 4 is a negative 2. So that's what this is. So this right here becomes this. Now here I'm going to distribute the negative 1. Negative 1 times x is a negative x, and a negative 1 times a negative 5 is a positive 5. So I got rid of the parentheses, I got these 4 terms. Now I'm going to combine like terms. 6x and a negative 1x is a positive 5x. So notice I said 6 and a negative 1 is 5. That's what it said. A negative 2 and a positive 5. So negative 2 plus 5, if you don't remember your sign numbers, use your calculator. That is just 3. So the answer is 5x plus 3. All right, so it's 16. Okay, now let's look at this. Sometimes it's going to say add, this would be 17. It's going to say add 3y minus 5, 3y minus 5, I'm sorry, wrong one, excuse me. Add 6x plus 7 to 4x minus 10. So add 6x plus 7 to 4x minus 10. Remember addition is commutative, so the order in which you add does not matter. So the direction is going to say here, perform the indicated operations. Indicated operations. Or it could say simplify. It could say something like that. Perform the indicated operations or simplify. So remember, you're adding these two expressions. So the order in which you add, remember, does not matter. So this I can say, remember, you're adding this to that. So it's kind of like saying adding 5 to, let's say, 4. Oops, let me write it out. Adding 5 to 4. So what that means is 5 plus 4, or you can say 4 plus 5. Does not matter. Okay? In both cases, that's a 5 here. In both cases, that's 9. Okay, that's what that means. So this becomes 6x plus 7 plus, and then 4x minus 10. That's all that is. And so you combine like terms, 6x and 4x is 10x, and then 7 and a negative 10 is a negative 3. So there's your answer. So adding is easy. It's subtracting that's going to be the issue for some of you. But it shouldn't be. It's not that difficult. So let's kind of review something from a previous lesson. So suppose I said subtract 2 from 6. 2 from 6. Now remember, subtraction is not commutative. So the order in which you subtract does matter. All right, so remember we said when we had this expression subtract 2 from 6, what that means. That means 6 minus 2. That's what that means. It does not mean 2 minus 6. That's wrong. It means 6 minus 2. So you're subtracting 2 from 6. So 6 goes first. So that's 4. So when we do this, number 18, suppose it said subtract 4x minus 7 from 12 plus x. 12 plus x. So subtract 4x minus 7 from 12 plus x. So remember, just like this, the 12 plus x comes first. So you can say 12 plus x. And you're subtracting this. So you got to put that in parentheses. So you're subtracting this expression. That's what you're subtracting. And so that now that looks like something we did earlier. So that kind of looks like this right here, or like this, or like this. Okay? So that's what that looks like. So you got to remember, subtract from, how to deal with that. Subtract this from that means put this first and then subtract this from it. Okay, now let's distribute the negative 1 through here. So this is 12 plus x. A negative 1 times 4x is a negative 4x. And a negative 1 times a negative 7 is a positive 7. And now combine like terms, a 1x and a negative 4x. So 1 plus negative 4 is a negative 3. So 1x and a negative 4x is a negative 3x. And then 12 and 7 is 19. So the answer is negative 3x plus 19. Okay, let's do one more with this. 19, suppose it said subtract 5m minus 6 from m minus 9. So 5m minus 6 from m minus 9. So again, subtract from. So you got to put this first. So this is m minus 9. Subtract, and you're subtracting this expression. So you got to put that in parentheses. You have to put that in parentheses because you're subtracting both of these terms. So distributing, we're going to get m minus 9. A negative 1 times 5m is a negative 5m. A negative 1 times a negative 6 is a positive 6. And so combine like terms, m and a negative 5m. So 1, remember that's understood to be 1 right here. So you add their coefficients. 1 and a negative 5 is a negative 4. So m and a negative 5m is a negative 4m. Your constants, a negative 9 plus 6 is a negative 3. So I get negative 4m minus 3. And so that's your answer there. Okay? All right, so that was the lesson on simplifying expressions using the distributive property. So we viewed the distributive property first from the previous lesson, and then we started noticing that when we do distributive property, I can still combine like terms. Okay, so that was the end of this lesson.